Howdy folks, welcome back. We're going to be looking at Shifrin 1.2.17 today, so that's chapter 1, section 2, problem 17. The problem asks that we prove that for any vectors x and y in Rn, that we have that the norm of x minus the norm of y is less than or equal to the norm of x minus y. And then we want to deduce that the absolute value of the norm of x minus the norm of y is less than or equal to the norm of x minus y. This might seem a little strange at first because it's like we have a weaker statement and we're deducing a stronger statement. We're just going to go ahead and kind of move straight through it, and we're just going to show this, and then we're going to use a similar technique to show that. Okay? All right. So let's start off with the first bit. This is what we want to show. So what we're going to do is we're going to use a really standard trick in analysis. I mean, you're going to see this all the time. I mean, if this is your first course in analysis, start getting used to this trick. I mean, if you've already taken a course in analysis, you know, you might be privy to what we're about to do here. Okay, so here's this trick. Here's what we're going to do. I'm going to start out with the norm of x. And I claim this is a pretty good place to start out because, well, I've got this part of the equation, or inequality so far, so I mean, at least I've got that, right? Somehow if I can just get some y over here, some norm of y on this side, right, and then have that somehow relate to this, I'll be good to go. In fact, sometimes if you're having an issue, it might help to try sort of deconstructing this inequality or looking at it slightly differently, like try adding this, and it might become immediately apparent. But here's what we're going to do. Here's the trick. Okay? It's a standard trick that you use when dealing with inequalities of norms. So if you have a norm and an inequality and you're totally stuck, it might be worth it to see if something like this works. What you do is you say, okay, the norm of x is equal to the norm of x minus y. Well, I've got my x minus y, but I mean, this is clearly not true. I mean, if I close this off, that's just false. I mean, unless y is 0, okay, but otherwise, yeah, it's just not true. So to fix that, I'm going to add y and close it off. And okay, well, yeah, then yeah, that's true. X minus y plus y. Well, yeah, these two cancel out, and you got x, and then the norm of x is equal to the norm of x. But the question is, why would I do that? I mean, I'm adding and subtracting y. I'm effectively doing nothing. Here's why. Because when you remember using, or if you remember from the previous, or from the section that if you read or if you saw the videos, the triangle inequality states that if you have the norm of two vectors summing, that's going to be less than the norm of one vector plus the norm of the other vector. So in other words, this vector, the norm of this vector, plus the norm of that vector is going to be bigger than this thing. To write that down, the norm of this one plus the norm of that one is going to be bigger than this thing right here, right? Maybe they're equal, but right, at least as big as. Okay? So how does that help me now? Well, look, I had the norm of x less than or equal to this thing over here. If I subtract by the norm of y on both sides of this, I'm going to have the norm of x, subtract off that norm of y, have my less than or equal to, and now I've just got a norm of x minus y, which establishes the first inequality, which is what I wanted. I wanted that first inequality. Okay, so now in a similar fashion, what we're going to do is try to show that this is true. And just so that you kind of see the game plan ahead of time, here's what we're going to do. If you remember, if you say something like the absolute value of x is less than some number c, that's equivalent to this statement. X, well, let me put less than or equal to since we have equality here, the non-strict version, right? Is between negative c and c. These two things are equivalent. It's saying the same thing. That's all this really means. So what this is really saying here is it's saying that the norm of x minus the norm of y should be between the norm of x minus y and the negative of the norm of x minus y. So we need to, if you notice, we've got this part already. That's what we just showed. What we want to show is we want to show this part right here, right? If I can show this, then I'm done. Then we're finished then, right? Because I'll have this part, and then from the first part of my proof, I have that part, so I can just turn it into a statement like this, which translates to that statement exactly. Okay, so that's our game plan. Our game plan is to show this inequality right here. How am I going to do that? Well, we're going to use a similar trick here. And maybe there's a clever way of doing this by using this inequality here. But we're just going to use this standard trick again, maybe get a little more practice at it. So here's what we're going to do. We're going to take the norm of y, and applying my same trick, I'm going to say, OK, x minus y minus x. Now notice, I mean, this is slightly different. There's maybe 1 or 2 extra steps here in our reasoning, but it's basically the same concept, right? The x and the minus x cancel. And then we have a y and a minus y, but since we're taking the norm, it doesn't make any difference. The norm of y is equal to the norm of negative y. The norm of x is equal to the norm of negative x. Makes no difference, right? So these two are equal. So in this case, by the triangle inequality, we could say that this on the left here is less than or equal to this on the right, which again, I applied that same reasoning that I just said right now, where we had the x minus y, gives us the x minus y. And then the negative x here, well, the norm of negative x is equal to the norm of x, so I'll skip a step and just go straight to writing plus norm of x. Why do I want that? OK, well, if I move the norm of x to the other side, right, I've got this, but I mean, how does that help me? I don't really want this. Well, remember, what were we trying to get? We were trying to get not norm of y minus x, but norm of x minus y greater than or equal to the negative. But look, I'm already set up. I'm primed for that, because if you remember, watch. If I multiply the left-hand side by -1 and the right-hand side by -1, I have to flip the inequality. And if I multiply by -1 over here, so I'll say, so the norm of x minus the norm of y is what I get after I multiply by -1. That becomes a positive, that becomes a negative, and I just switched their order. This becomes a negative norm of x minus y, right? And note that that negative doesn't just go away because it's outside the norm, okay? And I've got to flip that inequality. But look, that's exactly what I wanted. So I can say thus, the result here combined with the first, or maybe I should say along with the first, gives us that the absolute value of the norm of x, the absolute value of the norm of x minus the absolute value of the norm of y, the absolute value of the norm of x minus the norm of y should be less than or equal to the norm of x minus y, which is what we wanted to show. That's it. That's all there is to it. All right, hope you enjoyed the video. I'll see you next time.